Okay, let us start the problem regarding pipes in parallel. So the question is, a pipeline of 600 diameter and 1.5 kilometer long. To increase the discharge, another pipe of same diameter is introduced in parallel with the first pipe for the second half of the length. If 4F is equal to 0.04 and head at inlet is 300 calculate the increase in discharge. Neglect minor losses. So let us see what we have to calculate here. Here we have to calculate the increase in discharge. A pipe of same diameter but of half length is introduced at the second half length of the initial pipe. So let us see what are the given values. It is given diameter of the pipe is 600 which is equal to 0.6 meter, and length of the pipe is 1.5 kilometer, which is equal to 1.5 into 1000 equal to 1500 meter. And fourth, it is given 4F is equal to 0.04 and head at inlet is given as 300 or 0.3 meter, which is the head at outlet is 0 and head at inlet is given as 0.3. So we can say total head loss in this pipe is head at inlet minus head at outlet, which is equal to 0.3 minus 0, that is 0.3 itself. So HF is given as 0.3. Now in this question we have two cases. First case is discharge for a single pipe have to be calculated. This given figure, we have a tank which connected with a pipeline. Okay, and we have head losses 0.3, and the length of the pipe is 1500 meter, and diameter is given as 0.6 meter. Let it be the diameter of the pipe. So L is 1500 meter and diameter is 0.3. So we know discharge for a single pipe of length 1500 meter. We have to calculate the discharge for a single pipe. And in second case, in order to increase the discharge, they are introducing another pipe of same diameter but half length is introduced at the second half of this length, that is at 750 meter. So in first case, we have to find out the discharge. In second case, again we have to find the discharge when a new pipe is introduced. So let us see how to find the discharge. So we know HF. HF is the head loss, which is equal to 4FLB square by 2GD. This is the equation for calculating head loss due to friction. That is the major head loss. In the question it is given minor head losses are negligible. And in this equation 4F is given as 0.4 in the question, and G is 9.81 and D is 0.6. So let us substitute all those values. So I'm just substituting all the values. 0.04 into 4F is 0.04 and L is 1500 and we don't know the V. 2G and D are known, and HF we just found that HF is 0.3, that is inlet minus outlet head, that is 0.3. So from this equation we can calculate velocity, and we know discharge is equal to area into velocity. So discharge is equal to Q is equal to area into velocity, or we know the value of velocity. In order to calculate the value of area, we can find out it by using equation pi by 4 into d square. So by substituting all this value, you will get the discharge. In this case, that is only a single pipe of length 1500 meter is there. The discharge is 0.0685 meter cube per second. So this is the discharge for first case. Okay. Now let us go to the second case. That is, we are introducing an additional pipe of length 750 meter in parallel with the initial pipe with the last half of the pipe. That is, here we are introducing another pipe. Say this is pipe 1, this is pipe 2, and I am calling the discharge here. Discharge is Q. Here the discharge is Q1 and discharge is Q2 over here. And diameter at both sides diameter are same, that is D is equal to 0.6. So now we have certain sections, that is initial pipe of length 1500 meter and an additional pipe of length 750 meter from the half portion of the initial pipe. Okay. Now let Q1 and Q2 be the discharge in first and second parallel pipe. And Q is the discharge in main pipe. So this is the main pipe and we have two parallel pipes, Q1 and Q2. Since pipes are parallel, we know when we have two parallel pipes like this, if Q is the discharge and Q1 and Q2 are the discharge of two parallel pipes, then we have the equation Q is equal to Q1 plus Q2. So in the same case, we can say here Q1, Q2 is Q1 plus Q2 is equal to Q. Since the length and diameter of each parallel pipe, that is parallel pipe 1 and 2 are same, we can write Q1 will be equal to Q2. So when we substitute Q1 equal to Q2, this equation will become Q1 plus Q1. Q2 is equal to Q2, Q1 itself. So we can write 2Q1 is equal to Q, or from this we can find out Q1 is equal to Q by 2. Okay. So if you have same diameter and length, the discharge will be half, or discharge will be equal, and that will be the half of the discharge of from main pipe. Okay, it is clear? Okay. Now let us see. Let's consider the flow through ABC. I'm writing the value ABC, A over here, B over here, and C over here, and D over here. Okay. So we have ABC and ABD. Flow will occur in both directions. Let us consider the head loss at ABC. Head loss at ABC is equal to head loss through AB plus head loss through BC. So head loss through AB, from the equation that we have discussed just above, HF is equal to 4FLV square by 2GD, but 4F into, since it is of AB, head loss at AB is equal to 4F is constant. So LAB is given as 750 because we are introducing a new pipe at the half portion, right? So the length of this portion is half of the initial length, which is 750 meter, and this portion have the same length, and this pipe will also have same length, 750 meter. Fine. So length of AB is equal to 750, and the diameter of AB is same as initial diameter, that is 0.6 meter, and value of G we know 9.81, and velocity at AB, that we don't know. Okay. In order to calculate the head loss at AB, we should know the velocity value, right? So let me write velocity AB in terms of discharge and area. So velocity AB can be written as discharge of AB divided by area of AB. So what is this discharge AB? I'm calling it as Q. Discharge AB is Q itself, and area of the AB portion is pi by 4 into 0.6 square, or I can write 4Q divided by pi into 0.6 square, right, equal to 3.53 Q, right? So in this equation we have VAB square or V square AB. So V square AB will be equal to 3.53 Q whole square, which is equal to 12.5 q square. Okay, so I'm substituting the value in this equation. For if we know the value is given as 0.04, L we have 750, and for V square we have 12.5 into q square divided by 2 into 9.81 into diameter is 0.6. So the value is 31.85 q square. So we have the value of h of AP is equal to 31.85 q square. Similar way, let us calculate the head loss at BC. So we have length of BC is same as 750 meter and diameter is same as 0.6 meter, and VBC is equal to QBC by A, and QBC is Q itself. QBC was Q1, which is equal to Q by 2. So I can write Q by 2 divided by 5 by 4 into 0.6 square. So 4Q divided by 2 pi into 0.6 square, which is equal to 1.768 Q. Just multiply and find out the value. So we have V is equal to 1.768 Q. So VBC square is equal to 1.768 Q whole square, which is equal to 3.12 Q square. Okay. So I'm substituting the value in this equation, above equation, that is 4FL. In this equation, I'm substituting the value. So we have 4F is 0.04 into 750 into 3.12 q square divided by 2 into 9.81 into t is 0.6. Okay. So substituting all the value by doing the math, we will get the value as 7.53 into 7.95 q square. So we have the value of head loss in first case as well as in second case. So in first case, h of AB was equal to 0. H of AB was given as 31.85 q square, and h of BC is given as 7.95 q square, right? So from the equation we have h of ABC is equal to h of AB plus h of BC. And what is h of ABC? We know total head loss, that is 0.3. So 0.3 is equal to 31.85 q square plus 7.95 q square, which will come around 39.7 q square. Okay. So from this 31.85 plus 7.95 was 39.8 q square. So from this we know value of q is root of 0.3 divided by 39.8. 0.3 divided by 39.8, which will come around 0.0868 meter cube per second. So now we have the discharge in second case, that is when we introduce a parallel pipe, the discharge was 0.0868 meter cube per second. And in discharge, in initial discharge, that is before we introducing the parallel pipe, in case 1 the discharge was, what was the discharge? In case 1 the discharge was 0.0685 meter cube per second. So the difference in discharge is case 2 discharge minus case 1 discharge, that is 0.0868 minus 0.0685, and it will come around 0.0868 minus 0.0685, which is 0.0183 meter cube per second. See, when we introduce a parallel pipe of same diameter, at the mid of the pipe, we can increase the discharge by 0.0183 meter cube per second. I hope it is clear.